Here's problem number 53 from section 8.4. We want the area under the curve in the first quadrant for this particular curve. Well, let's start by saying, well, what does this particular curve look like? Well, when x is equal to 0, it's at its highest at 1. And as x gets larger, the denominator gets larger, the value of the function gets smaller. You end up getting something like this. So, our first quadrant curve, and this expression value is never negative, it never crosses there. So our first quadrant area is the integral from 0 to infinity of 1 over x squared plus 1 dx. Now, since this is improper, let's rewrite it. The limit as b approaches infinity of the integral from 0 to b of 1 over x squared plus 1 dx. We already recognize that antiderivative as the antiderivative, or this is the derivative of the inverse tangent function from 0 to b, which means you're getting the inverse tangent of b minus the inverse tangent of 0. Now, if we recall what the inverse tangent function looks like, well, tangent function looks like this. At least one part of it is bound between negative pi over 2 and pi over 2. The inverse tangent is this curve reflected over the line y equals x, and in doing so we get this function here. For this function, the inverse tangent function has an asymptotic behavior to pi over 2. So as b goes to infinity, inverse tangent of b approaches pi over 2, and the tangent of 0, inverse tangent of 0 is 0, so pi over 2 is our area.